Hi students, this is 2.1, adding and subtracting polynomials. A couple of things I want you guys to keep in mind. We make sure you have your title. Also make sure you put your name, today's date, and period. Make sure it's also written in pen. Everything else you can do in pencil or you can keep it in pen. It really doesn't matter. So before I get started into our notes, I would like you guys to draw or create something like this, half sheet of paper. I totally forgot to add it into our notebook, so we'll go ahead and do that now. 2.1 is about adding and subtracting polynomials. The first thing we want to know is, what is a polynomial? The essential question is, how do you add and subtract polynomials? Well, a polynomial is an expression that contains constants. So we have numbers like 1, 2, and so forth. Variables. Variables are letters. So we have X, Y, Z, R, S, T, A, B, C, letters of the alphabet. And we have exponents. So, that is what a polynomial is. Before we get into our examples, polynomials are named according to their degree and the number of terms. So the first thing I want you guys to focus your attention on, and again, stop the video, go ahead and write all of this down before we actually get into the examples, because I forgot that we need to know the names. So for a polynomial with one variable, the degree is the largest exponent of that variable. So we'll get into that in the examples in just a moment. So if you have a 0 degree, we call that a constant. That means it's just a number. 4, -3, +2, those are some examples. If it has a degree of 1, we call that a linear. A degree of 1, again, you have that imaginary 1. You have the imaginary 1, so you have a degree of 1. So this is 2x, 5y, z. It has a degree of 1, so we would call this linear. Some of you guys are familiar with these names, so that's great. Degree of 2, so if it's squared, we have a quadratic. Some examples would be x squared, 3z squared, okay? And it just doesn't have to be just one term. It could be 3x plus 2x squared, because x squared is the largest exponent of that variable, then we will call that a quadratic. 3 is cubic, so if it has an exponent or a degree of 3, we call that cubic. So 2x cubed, y cubed. 4 is quartic, 7x to the 4th, z to the 4th. Again, you can have more than one monomial. 5 is quintic, y to the 5th, 3z to the 5th. Again, we're looking at the largest exponent. And then anything that has a degree of 6 and on, like 6 degree, 7 degree, we just call it that. You can have something like x to the 6th plus 1. So we know that the largest exponent is 6, so it's 6th degree. Okay. Now, at the same time, the terms are always separated by a plus and a minus sign. And there's a name for however many terms you have. So I had mentioned the name monomial because that means that there's only one term. So one term is a monomial, which means this is an example of one term. It's 5x. These were examples of monomials. Binomial, bi means 2. Okay, so again, remember the terms are always separated by positive and negative numbers. So here's a negative sign. Here's a negative sign or a minus sign. That means we have two terms here. We have 2y to the 3rd power minus 7. Okay, so we would call this, again, when we're naming polynomials, we name them according to the degree and the number of terms. So the highest degree here would be 3, so we would call this a cubic binomial. Okay, because the highest degree or the largest exponent is 3. Number 3 is a trinomial. Tri means 3. We have 3 terms here. Anything with 4 plus terms, we call that a poly. Poly means many, polynomial. we have y cubed plus y squared plus y plus 5. Remember, when we're naming the following polynomials, we name them by the degree and the number of terms. Okay, so this is your vocabulary. Again, create this in your 2.1 notes before we get into the examples. You can use this as a guide. Okay. All right. So here we go. We're going to fill this in together. Please follow along. Again, my request is that you would pause the video and you would write all of this down so we can go ahead and get started. Example 1 is going to ask you write the polynomial in standard form. Identify the degree and the leading coefficient of the polynomial. Okay. Just a moment. Okay, so you're probably asking yourself, what is standard form? In your textbook, on page, I'm looking at my textbook right now, 63. You have a bunch of core concepts called classifying polynomials. And it's a bunch of vocabulary that we had just gone over. But let me talk about standard form. A polynomial in one variable is in standard form when the exponents of the terms decrease from left to right. Okay, so standard form when the exponents of that term is decreasing. So we want to start with the largest exponent, and then from left to right, it's going to be in descending or decreasing order. Okay, so couple things. I'm going to color coordinate this and abbreviate. Standard form, I'm going to use SF because we're going to have to, you're going to have to do this in your homework. So I'm just going to call this SF, standard form. What we want to do is take this polynomial, look at the degree. So we have a 1 here. We have a 3 here, and there is a 0. This is a constant. Okay, start with your largest degree, largest exponent, and then decrease from left to right. So it would be negative x cubed. Okay. And then we go plus 15x, and then our constant, plus 3. Okay, so we're starting with our largest degree. Okay, identify the degree and leading coefficient. Degree, we have a degree of 3, which is also known as a cubic. And the last thing is your leading coefficient. I call this your LC. Leading coefficient. Once it's in standard form, it is that number that is in front of your variable. So we have an imaginary 1 here because there's a negative in front of it. This would be considered a negative 1. Okay. We're going to do that again, probably a little faster. So standard form. Again, we're looking at our exponents. We have a degree of 1. We have a constant here, and this is an exponent that is 2. 2 is our largest degree or exponent, so it's going to be 9x squared minus 2x minus 8. Okay. Standard form, the next one is degree. I had mentioned earlier, it's the largest degree, which is 2, also known as quadratic. Also known as quadratic. Again, I'm looking at this. I might upload this form if you want to print it out and tape it into your notebook and then start your notes. Leading coefficient. Once it's in standard form, please do not look at what they give you. Once you place it in standard form, leading coefficient is the number that is in front of that variable. Leading coefficient is 9. Okay. All right. So there are your answers right here. Box, highlight, do both. I want to see answers. Okay. Okay, let's continue. Again, we have some vocabulary. This is example 2. It's going to ask you to write each polynomial in standard form. We already know what standard form is, okay? We're starting with our largest exponent, and then we're going to decrease from left to right, okay? All right, identify the degree and classify each polynomial by the number of terms. Okay, so we're going to classify, that means we're going to name, classify each term, each polynomial by the number of terms. So 1 is monomial, 2 is binomial, 3 trinomial, 4 is polynomial. Okay. All right, so we have 2 examples. Again, I just created this, and when you do your homework assignment, you can also create something like this, just so that you don't have to keep writing over standard form, degree, and type of polynomial. Okay, let's take a look at the first one. We have 4 plus 5x squared minus x. Let's go ahead and put this in standard form. Okay, standard form, we're starting with, we have a 1 here, 2 here, a constant there. So we're going to start with 5x squared. That's the largest exponent. Now we're going to decrease from left to right. You don't necessarily have to put a positive 1 there. We know it's there. And then we have plus 4. The largest, when it asks for degree, we want the largest degree. So our largest degree is 2. And the type of polynomial that we have, remember, students, the terms are always separated by plus and minus signs. So we have 1 term here, then we have a minus sign. This is our second term, plus sign. This is our third term. So a polynomial that has 3 terms, we call that a trinomial. And there you have it. All right, let's take a look at the next one. We have 8q plus q to the 5th power. Okay, 8q plus q to the 5th power. All right, standard form. 5 is larger than 1, so we're going to start with our largest exponent, q to the 5th plus 8q. Degree, which is 5, also known as quintic. And the type of polynomial, how many terms does it have? It has 2 terms. We call that a binomial. So it just requires, if you guys are not familiar with this vocab word, then you just have to practice. And we'll do a lot of that during the time that we have together. Okay. All right, let's take a look at example 3. Adding and subtracting polynomials. Now that we've identified what a polynomial is, when it's in standard form, degree, type of naming polynomials, let's go ahead and start adding and subtracting. There's several different ways that you can do this. You can do what we call the horizontal format or the vertical format. It really doesn't matter, okay? If you want to try the vertical format, again, this is on page 64 of your textbook, and it will show you both formats. You're basically taking one of the terms, probably the second term, and you're putting it under, you're matching it up to the exponents, and you're adding or subtracting, okay? The horizontal is you're just identifying which terms, which are like terms, and then you're going to combine them. Me personally, I like the horizontal format. Okay, I like to color code them. I also have highlighters here, just so that you can see what are like terms, and then we can add or subtract them. Okay, so I'm gonna color coordinate them. I have 2x to the 3rd power. Okay, that has to the 3rd power, and I have positive x to the 3rd power. Now, there's an imaginary 1 there. They're both positive. So basically what we're going to do is we're going to add the 2 and the 1. 2 plus 1 is 3. 3x to the 3rd power, 3x cubed. And that's how I'm going to do it. You can highlight this. You can circle it. You can put, whatever you're comfortable with. You don't have to do anything. Okay? You don't have to do all this highlighting. But I'm showing you what terms are alike. Okay, now we have a negative 5x squared and we have a positive 2x squared. You have a negative 5 and a positive 2. Negative 5, positive 2, we are subtracting, and we're going to keep it negative. And that's going to give us a negative 3x squared. And the last one, let's take a look at it. We have x. Notice how we do not have an exponent of the power of 1. So we're just going to bring that down, plus x. And don't forget this constant. This constant is by itself. We have to bring that down as well. So our final answer, when we're adding our polynomials, is going to be 3x cubed minus 3x squared plus x minus 1. Okay. All right, let's keep going. Okay, again, we're going to move a little bit faster. Let's go ahead and take a look at our like terms. We have 3x squared and we have x squared here. Remember, they're both positive, so this is going to be 4x squared. All right, we have x and we have a 4x. Again, we have imaginary 1 there. 4x plus 1x is 5x. And look at that, we have constants. Both of them are constants. Negative 6 and a positive 10. We are going to subtract, keep it positive. That will give me a positive 4. Final answer is 4x squared plus 5x plus 4. Again, the highlighting is not only for it to look beautiful, but it's for you to be able to organize and separate your like terms. Okay, we have one more, which is going to be, I'm assuming, subtracting polynomials. What do we do when we are subtracting polynomials? So we know subtraction, there's probably going to be a negative. All right. And these are our last two examples. And we can go ahead and get started on our homework assignment. So I'm going to zoom in on this. Okay, so there is something about when you have a negative on the outside of the parentheses. Anytime you have a negative on the outside of the parentheses, you are going to distribute. Distribute, okay? We are going to distribute that. There's actually an imaginary 1 there, and because of the negative, there's a negative 1. So we're going to take this, we're going to distribute this negative 1 into the parentheses. And guess what, students? That is going to change the sign. I'm drawing arrows so you know it goes to each term. This is a trinomial. It's going to go to each term inside the parentheses. Okay? I draw these arrows not because, again, I draw these arrows because a lot of students will multiply and then they'll forget the other terms that are inside the parentheses. This is just a reminder that it needs to be multiplied to each term. So 4x squared is going to stay the same, plus 5. This is where it's going to change. A negative times a negative. We now have a positive 2x squared. A negative 1 times a positive 2x is now a negative 2x. A negative 1 times a negative 4 makes it a positive 4. Now, do we have any like terms? Take my highlighter. I'm going to take my highlighter, highlight. Whoops. Okay, so I'm not going to highlight. I'm just going to circle. We have positive 4x, 4x squared, and 2x squared. They're both positive, so that gives me 6x squared. Okay. Any other like terms? Again, we want to make sure you put the answer in standard form. So we have negative 2x. Bring that down, negative 2x. And then we have constants. Okay, we have a constant positive 5 and a positive 4. That gives you positive 9. And there you have it. There's your final answer. Again, it's in standard form. 6x squared minus 2x plus 9. Okay, so we're going to do it again. There's a there's a negative 1, and we have two parentheses. It really doesn't matter about the first set of parentheses. It is the second set because there's a negative 1 in front of it. Okay, so let's show some work, students. Draw my arrows. Okay, before I start multiplying that out, I'm going to bring this down. 4x squared minus 3x plus 5. That's not going to change. It's everything here in the second set of parentheses. A negative 1 times 3x squared is a negative 3x squared. A negative 1 times a negative 1x, or negative x, is a positive x. Negative 1 times a negative 8 is a positive 8. Now, do you see any terms that you can combine? I'm going to underline them. We have a 4x squared and a negative 3x squared. Because we have a positive 4 and a negative 3, we're going to subtract, keep it positive. I end up with positive x squared. Okay. Take a different highlighter. Again, you don't have to do the highlighting. I like it. Okay, we have a negative 3x and a positive 1x. Subtract, keep it negative. And the last one that we have, positive 5, positive 8, that gives you positive 13. There's your final answer. Again, students, I am showing my work. I'm boxing my answers, and I'm trying to use the best, writing that I possibly can for my teacher, okay? And that's what you guys should be doing. Thank you.